Okay, so A to B, the body starts. Please mute, get muted if you haven't. The body starts from rest. Please mute. I'm getting a very bad feedback here. Okay. So A to B, the body starts from rest, then accelerates uniformly to a point B, then maintain the speed from B to C, then decelerate uniformly to rest. That's just the motion. I take it again. A body starts from rest, accelerate uniformly to a point B, then maintain the speed from B to C, then decelerate uniformly to rest. That is a motion. Now, if I should change this, I want to modify this a bit. Instead of starting here, this is A. This is B. Yes, describe the motion. What is happening here? What is happening here? Yes, a quick observation by one of you. If we have it as this, what is happening?
Because see like the initial velocity the body started moving from initial velocity A.
Good. That's just, and then so the body starts with a certain initial velocity, okay, at the point from the point A, then go ahead, then
accelerates uniformly to B.
So then accelerate uniformly to B. Then maintain the speed from B to C and decelerate uniformly. Decelerate uniformly to what?
D.
To rest at point D. All right. So a body starts with a certain initial velocity from point A. So here the difference is that the body is not starting with an initial velocity of 0, but it has a certain value of initial velocity from point A. Then accelerate uniformly to a point B. Then maintain the velocity from B to C. Then decelerate uniformly to rest. So its final velocity when it comes to or gets to a point B is equal to 0. That's the motion. Whenever you determine a slope under a velocity time graph, the slope under a velocity time graph is equal to
acceleration.
Is equal to the acceleration. So if I have set a motion and you ask me to find the acceleration, okay, at a point AB, it means I'll just look for this slope. I'll look for the slope here from A to B, changing this vertical over the change in the time. Okay. If you ask me to find the deceleration, I'll find the slope of this line from C to D, and that is change in this vertical over the change in the horizontal. This slope would give me the deceleration, whereas this slope would give me the acceleration. But how do I get the acceleration between the points B to C? Yes. How do I get the acceleration between the point B to C? A quick observation. How do I get the acceleration between the point B to C? That is, that is
0 because the velocity is constant.
yes, there is no slope. There is no slope. So the acceleration is 0. So these are things you have to look out for. All right. Now, another observation. The area under a velocity time graph. If you have a velocity time graph, the area under it. An example is this. I have this velocity time graph, and this is the whole area under it. The area. This is the whole area under this velocity time graph. So two, the first one is that slope, the slope under the velocity time graph is the acceleration. Two, the area under a velocity time graph. V dash T. The area under a V dash T graph is equal to the total distance covered by the body. Are you there?
Yes, please.
So the area under a velocity time graph is equal to the total distance covered. So look at this area, whole area I have on the board. This represents, when I find this area, I have found the total distance covered by the body. When I find this area, I have found the total distance covered by the body. So these are two important things we can deduce from velocity time graphs. Any question? Any question? No question. All right, quickly let's look at equations of motion. I'll be sending you graphs of motion questions to answer. Okay, as you go through it, I mark, you get better under velocity time graph and displacement time graph. All right. Okay.
Yes.
Please, I sent you a couple of graphs, about 2, 3. Very, very, very important. Okay. Copy the graphs into your notebook. I remember I gave you, I think, velocity displacement time graph, velocity time graph, and even added acceleration time graph, right?
Yes, please.
Copy them into your notebooks. Very, very important. Okay. Equations of motion. Equations of motion. Just as we can represent the motion of a body, okay, along one plane, one-dimensional motion on a graph, we can also mathematically express or describe equations of describe the motion of a body. But this is using equations or mathematics, hence equations of motion. All right. Now, our equations of motion works on when a body is in a uniform accelerated motion. Okay. So basically, we can say equations of uniformly accelerated motion, implying that when the motion is not uniformly accelerated, you cannot use the equations in describing or determining some information about the motion. So the equations apply when the motion is uniformly accelerated. Okay, meaning that when the rate of change of velocity with respect to time is what? Constant. So considering a body in a uniformly accelerated motion of initial velocity u, final velocity v, and within a time interval of t. So this is our foundation. We are considering a body in a uniformly accelerated motion with initial velocity u, final velocity v, within a time interval of t. Are we fine?
Yes.
Good. I want you to help me determine the acceleration of this body. Help me determine the acceleration A of the body. Yes. What's the acceleration of the body? Agree?
V minus U over T.
Good. So since, thank you, since acceleration is changing velocity with time, this will be equal to the final velocity v minus the initial velocity u over t. Help me, class, help me make v the subject. Help me make v the subject. V would be equal to
V will be equal to
U plus 80.
good. Come again.
Equal to U plus 80.
All right. So V would be equal to U plus 80. And class, this becomes the first equation of motion. First equation of motion. That becomes the first equation of motion.
Mr. Adria,
Hello.
Mr. Can I read the question again? My board is not clear.
Really?
Yes,
I'm
please.
I'm taking a consideration. It's not a question per se, but it's a consideration. We are assuming that or considering a body in a uniform accelerated motion with initial velocity u, final velocity v, okay, change in velocity occurring within a time interval t. So that's the consideration. So if you have an accelerated motion in this manner, how do you calculate the acceleration? The acceleration is determined by, obviously we know acceleration is change in velocity with respect to time. So the acceleration of the body here would be final velocity v minus initial velocity u, or divided by the time interval. Are you okay? Now, whenever a body accelerates, what happens? Whenever a body accelerates, what happens? Its velocity will change.
Yes.
And when velocity changes, it would equally cover a certain distance, right?
Yes, please.
So let us represent the distance covered by the body, by the accelerating body. So let us represent distance or displacement by the body within the accelerating period. Now, if we want to find the average velocity of the body, let's find average velocity. Average velocity, which we often represent as v bar. Or v subscript AVE. How do we determine the average velocity of the body? Yes. Somebody to try for us. How do we determine the average velocity? Let me go to
The total distance over total time.
good. So we can determine average velocity, okay, in two different ways. The first one is when you have total distance covered divided by total time taken. And what's the total distance covered here? Yes, what's the total distance covered?
S.
S.
So
S.
small letter S, not a big S, oh, divided by the time taken. The time interval is actually total time taken is T.
C.
So V bar or V average is equal to S on T. Another way of determining average velocity V bar is this. V bar is equal to, please, in your mathematics lesson, when you are given two numbers to find the average, how do you do that? I've given you 2 and 5, find the average. How would you do that?
The total over 2.
So the sum of the two numbers, okay, divided by the number, or the what we sometimes call as the sample space. So if I give you 3 numbers, 5, 6, and 4 to help me find the average, how would you do that?
You
5
divide by
plus
you
6
add
plus
5,
6.
6, and 4.
You add the
Divide
numbers.
Divide by 3.
Good. So the sum of the numbers divided by the sample space, the number of the data is giving me, right? So we are talking about average velocity, and within the period of accelerated motion, we have two velocities in place. We have u and v, and so it's obvious we can determine the average velocity v bar by summing up the two velocities u plus v and dividing by what? And dividing by
2.
2. Good. So this is another way of determining average velocity, and the value is the same. So, okay, all right. I thought it's a question. And so, because this is average velocity, and this one too is average velocity, we can equate S over T to U plus V over 2 because they are all equal to the average velocity V bar. That's how we find. Are we okay?
Yes, please. Yes.
Okay, if you have any question, quickly ask before we continue.
Celia.
Yeah. Hello.
So this is the actual equation.
We haven't ended, but we are working to equation 2 and 3. We have equation 1. We are moving on to equation 2 and 3.
Okay, thank you very much.
Welcome. All right. Now, let's make S the subject. S from here would be equal to S okay. U plus V on 2.
Over 2, all multiplied by T.
Good. All multiplied by T. Then let's substitute.
Mr. Dia, please, I can't see the board.
Hello, is it a general problem?
No, please.
No, please.
Oh,
Please, I can't
then
see the board.
Rejoin. Okay. Rejoin. It's a network problem. Yes, go ahead and what's the name? Crilly.
Mr. Dia, please, I can't see the other side of the board.
Really?
Okay, that one is green.
It's blurry.
Blurry.
Yes, please.
Okay. When I write at the side of it, can you see?
Yes, please.
Okay, then let me write at this end of the board rather. So we have S being equal to U plus V all on 2 times T. Let's substitute equation 1. Into this equation. So substitute equation 1, the first equation of motion, into what the equation I have labeled as star. And equation 1 is V is equal to U plus AT. When we do the substitution, wherever we see V in the equation indicated as star, let's put this. So I have S is equal to U plus V is this. U plus AT. Meaning this is equation 1, okay? All divided by 2 with a T outside. Are we fine?
Yes, please.
No, please.
Go over that side again.
So let me go over it for the last time. All that we are doing is we have S is equal to U plus V all on 2 times T. Okay, and we are substituting equation 1, which is V is equal to U plus AT, into it. Meaning within this equation, wherever we find V, we are going to put this. All right? All right?
Yes, please.
Good. So I have found V in this part of the equation. So I'm going to substitute this. So S is equal to U plus another U plus AT, and this is for V. All divided by times the T outside the bracket. I hope all is well.
Yes, please.
Then I play around this. Okay, I have U plus U. This is 2U plus AT all divided by 2 times T. Let me divide whatever I have within the bracket by the denominator. So 2U divided by 2 plus AT divided by 2. I have T outside the bracket. Okay, 2 cancels 2. I can now multiply through by the T outside the bracket, isn't it?
Yes.
Okay, so do it for me. What will be the final equation here?
S is equal to UT plus AT squared on 2.
So UT plus AT squared on 2 becomes the second equation of motion. I have the second equation of motion. Isn't it beautiful?
Yes.
As for this, even if it's not beautiful, it has to be beautiful. All right. Please, if you are copying, quickly do so, and then let's continue. We are left with the third one to derive, and we are done with equations of motion. Can I clean the board?
Yes, please.
Gloria, please mute.
Okay. Do I continue? Okay, silence means I can clean.
Celia,
Hello.
please, can you write this equation as S is equal to UT plus 1 over 2 AT?
Exactly.
Okay, thank you very much.
Welcome.
T square.
Okay, so I want to clean the board so we can derive the third one. Actually, the foundation of equation 2 and 3 actually hinges on your understanding of the average velocity. The moment you understand where to obtain the average velocity, you are there. Kelly,
So please, so does that mean that the second equation of motion is also the formula for finding average velocity?
though, you see, what I'm saying is that the second equation, the third equation depends on the average velocity thing. Okay, once you understand that average velocity is total distance covered divided by total time, and it's also equal to initial velocity plus final velocity divided by 2, you can easily extract equation 2 and 3. That's what I mean.
Yes, please. Thank you.
Welcome. So equation 3. Yes, as I said, it depends on the average velocity. So knowing that average velocity is equal to total distance taken, S, divided by T, and it's also equal to U plus V over 2.
Celia, please,
Yeah.
what you are writing, it's too high. The camera is not really capturing it well.
I'll capture it for you. Is it captured?
Yes, please.
Okay. So this is all that I need to derive equation 2 and 3. Okay, so S is equal to U plus V on 2 times T. From equation 1, the same equation 1, make T the subject. So make T the subject from equation 1. Yes, somebody to help me.
V minus U over A.
So T is equal to V minus U over A. Good one. Let's substitute this into our equation star. So when we do that, S is equal to U plus V on 2 times V minus U on A, isn't it? Because addition is commutative, instead of U plus V, I can write it as
V plus U.
good, V plus U. Now, if you have A plus B times A minus B, how would you express this? How differently can you express this?
A squared minus B squared.
And the name given to this is
Differences of 2 squared.
so difference of 2 squared. So we can apply difference of 2 squared to the numerator. Okay, we have V plus U times V minus U, all divided by 2 times A. So the numerator can be simplified as V squared minus U squared, all on 2A. Now help me make V squared a subject. Help me make V squared a subject. If you are ready, you tell us. Yeah, who is ready?
2AS plus U squared.
So V squared is equal to U squared plus 2AS, or 2AS plus U squared. Addition is
Commutative.
commutative. And this is the third equation of motion. We are done. We are done. Can't you prove these 3 equations when you are asked to? Can't you prove this? Because you can't prove, you are fine. So we have 3 main equations. Equation 1.